Marco. Polo. All right, so I got your attention. So let's do a couple more of these, starting with number 14. So on 14, we have 8 to the 2x is equal to 8 to the x plus 7. This one is super easy. If the bases are the same, like 8 and 8 here, well, just get rid of them. If the base is the same, the exponents have to be the same. So 2x is equal to x plus 7. Subtract the x over, x is equal to 7. That's it. Done. Finished. Okay. Now, let's move on to number 15. No, wait. There's no... Ah. Here, I'll just put 15 right over here. I wanted to do 15. Okay, how about 15. 7 to the 2x minus 3. All of this minus 4. All of this is equal to 14. Okay, we're going to isolate that 7 first. That's 7 to the 2x minus 3. Where did my minus sign go? Anyway, add the 4. I get 7 to the 2x minus 3 is equal to 18. Now, how do I get rid of that 7? Well, it's exponential, so I'm going to take the log of both sides. Let's take the natural log because everybody likes it better. 2x minus 3 is equal to the natural log of 18. Okay, now again, natural log and base 7 do not cancel out, so I'm going to use the power property to take this exponent here out front. So in parentheses, I'm going to have 2x minus 3 times the natural log of 7 is equal to the natural log of 18. Now let's see. This natural log of 7, what is it doing to this set of parentheses here? It's multiplying. Why don't we just get rid of it? Why don't we just divide that right over to the other side? And I'm going to have 2x minus 3 is equal to the natural log of 18 divided by the natural log of 7. There we go. So basically what that just did is change the base from 7 to e. And now I have the exponent that I'm dealing with. Add the 3 over. 2x is equal to this whole natural log business. 18 over natural log of 7. Add the 3. And now I've got to take that whole thing and divide it by 2. So let's divide by 2. So if I were you in my calculator, and this can get pretty complex, just go ahead and type this in first. So I got natural log, open the parentheses, 18, close the parentheses, divided by natural log of 7, hit enter, now hit plus 3, get an answer. Now divide that answer by 2. What you should get is x is approximately equal to 2.243-ish. That should be good. Okay. Give you a second to catch your breath. And then we're going to move on to number 21. There we go. Number 21. So look, I've got two different bases here. I've got 8 and I've got 1/2 on the other side of it. The thing is that I can make those the same exact base because both of those things are powers of 2. Powers of 2. In other words, 8 is the same thing as 2 to the 3rd power, right? And 1/2 is the same thing as 2 to the negative 1 power. Right? So all I did was I just rewrote those bases. Now I need the original exponents. So 2 to the 3rd raised to the x minus 1 power is equal to the negative 1 to this original 2x minus 1 power. Okay? So again, let me go back a step here. They had different bases, but this was a special case where both of them could be rewritten as powers of the same base. In this case, 2. Because 8 is the same thing as 2 to the 3rd, and 1/2 is the same thing as 2 to the negative 1. Now, if the bases are the same, then the exponents have to be the same. So we're just going to write these exponents as being equal to each other. 3 times x minus 1 is equal to negative 1 times 2x minus 1? Yeah, I think so. Okay, so distribute our 3 through the first set of parentheses, 3x minus 3. Distribute the negative 1 through the other one, minus 2x plus 1. Now let's just solve this thing for x. Let's get our x's over here to the left, add 2x. And we got 5x minus 3 equals 1. And add our 3 over, 5x equals 4. And then finally, divide. We get 4/5. That was fun. I think that we have time for a couple of more here. Let's look at, and by a couple I mean one more for this video anyway. Let's look at number 22. 22, 3 times 2 to the x plus 6 is all equal to 17. Okay, so I want to isolate the exponential term by first getting rid of that 3. To get rid of that 3, let's just divide by 3. Divide by 3. Now when I divide by 3, that does not affect that 2 that's right there. Because if I multiply this thing, I'm basically multiplying by a third, so it's only going to get rid of this 3 in the front. It's not going to affect that 2 that's right here. Okay, so I'm going to have 2 raised to the x plus 6 power is equal to the fraction 17 over 3. Now I got to get rid of this. It's an exponential equation. I'm going to take the log of both sides. It's a base 2, so let's just go ahead and use natural log because that's what we do. Nick, Nick, put the stapler down. Tape? Who gave you that tape? Thank you. All right, you're taking notes, right? You're doing these problems with us? Okay. All right, so let's take the log of both sides. 2 to the x plus 6 is equal to the natural log of 17/3. Okay, again, natural log and 2 do not cancel out, so I'm going to use that property again to pull out that x plus 6 business. X plus 6, it's going to be in parentheses, times the natural log of 2 is equal to the natural log of 17/3. Again, what is the natural log of 2 doing to this set of parentheses? It's multiplying, so to get rid of it, let's just divide it. Divide both sides by it, and it's going to get rid of it on the left, and I have x plus 6 is equal to the natural log of 17/3. All of that divided by the natural log of 2. So just like we did before, basically what that just did was change the base from the original 2 to e so that I could put it into the calculator. And then that was equal to that exponent that's right there. And then finally, let's subtract the 6 over. So x is equal to the natural log, like I want to write this again, 17/3 over the natural log of 2, all of this minus 6. So when you put this in the calculator, my suggestion is just put this fraction in there first, natural log of 17 divided by 3, close your parentheses, divided by the natural log of 2, hit enter, subtract the 6 from it, and we should get negative 3.49. What is going on? Negative 3.497. Okay, so we're going to stop this video for right now. What I want you to do is go back, problems that you haven't done yet on this page, on page 119, 13 through 27. I want you to do the odds, and then we'll come back and we'll look at some logarithmic equations once you have a chance to rest a bit. All right.